Chapter 8, Part 2. Biological motivation, hunger, and eating. Energy homeostasis. Calories consumed equal calories expended. Food is converted into amino acids, fatty acids, and simple sugars, providing fuel for your body. The simple sugar glucose, or blood sugar, provides the main source of energy. In the liver, glucose is converted to and stored as glycogen. The hormone insulin, secreted by the pancreas, helps control blood levels of glucose and promotes the uptake of glucose by the muscles and other body tissues. It also helps in regulating eating behavior and maintaining a stable body weight. Basal metabolic rate, BMR, is the rate at which the body, when at rest, uses energy for vital functions such as heartbeat and respiration. Adipose tissue, or body fat, is the main source of stored or reserve energy. Positive versus negative energy balance. Your typical or average body weight is called your baseline body weight. A regulatory process called energy homeostasis, the long-term matching of food intake to energy expenditure, helps you maintain your baseline body weight. Over time, most people experience energy balance, so body weight, including body fat stores, tends to remain stable. Positive energy balance occurs when caloric intake exceeds calories expended for energy. The excess glucose is converted to body fat. Negative energy balance occurs when caloric intake falls short of the calories expended for energy. Body fat stores shrink as the reserve energy in fat cells is used. Short-term signals that regulate eating. There are physiological changes that predict eating. About 30 minutes before you eat, you experience a slight increase in blood levels of insulin and a slight decrease in blood levels of glucose. Even if you do not eat, glucose will return to its baseline level. The hormone Ghrelin, or hunger hormone, which is primarily manufactured by cells lining the stomach, is also involved in the short-term regulation of eating behavior. Prior to eating, body temperatures increase and metabolism decreases. As the meal is consumed, this internal physiological pattern reverses. Psychological factors that trigger eating. Through classical conditioning, the time of day at which you normally eat acts as a conditioned stimulus and elicits reflexive internal physiological changes, the CR, or conditioned response, which increases your hunger. Operant conditioning and positive reinforcement play a role in eating. Voluntary eating behaviors are followed by a reinforcing stimulus, the taste of food. Due to prior reinforcement, certain tastes, especially sweet, salty, and fatty tastes, hold a greater positive incentive value. Satiation is the feeling of fullness and diminished desire to eat that accompanies eating a meal. Stretch receptors in the stomach that communicate sensory information to the brainstem. The hormone CCK, secreted by the small intestines, promotes satiation and reduces or stops eating. There is also sensory-specific satiety, the reduced desire to continue consuming a particular food. You might be tired of eating your hamburger but still want those fries. Long-term signals that regulate body weight. 3 of the best documented internal signals are leptin, insulin, and neuropeptide Y. Leptin is a hormone secreted by the body's adipose tissue into the bloodstream, and insulin is secreted by the pancreas, both in direct proportion to the amount of body fat. Increases in leptin and insulin acting on receptor sites in the hypothalamus reduce food intake. Decreases trigger eating behavior. During periods of negative energy balance and weight loss, decreased leptin and insulin levels promote the secretion of neuropeptide Y, NPY, by the hypothalamus. NPY triggers eating behavior, reduces body metabolism, and promotes fat storage. In combination, the long-term and short-term eating-related signals provide a feedback loop monitored by the hypothalamus. Over the course of time, energy balance is achieved. Eating and body weight over the lifespan, set point or settling point. Set point theory proposes that humans and other animals have a natural or optimal body weight, called the set point weight, that the body defends from becoming higher or lower by regulating feelings of hunger and body metabolism. Settling point models of weight regulation suggest that body weight settles or stabilizes around the point at which there is balance between the factors influencing energy intake and energy expenditure. Excess weight and obesity is an epidemic. In the United States today, 64% of adults are either overweight or obese. The Body Mass Index, or BMI, provides a single numerical value that represents adult weight in relation to height. Factors involved in becoming overweight include the following. Inadequate sleep disrupts the hunger-related hormones leptin and ghrelin. People often eat because of the positive incentive value of the available food. People overeat because of the Supersize syndrome. Much larger portions are offered for only a few cents more. People overeat because of the cafeteria diet effect, the tendency to eat more when a wide variety of palatable foods is available. 43% of women and 37% of men lead sedentary lifestyles, in other words, couch potatoes. Basal metabolic rate is 3 to 5% lower among women than among men, and it decreases by almost 2 to 3% per decade of life. According to John P.J. Pennell and his colleagues, the behavior patterns of sensory-specific satiety and the cafeteria diet effect, combined with the positive incentive value of consumption that are far higher than those that are compatible with optimal health and long life. Many obese people experience leptin resistance, in which the normal mechanisms through which leptin regulates body weight and energy balance are disrupted. Many overweight or obese dieters experience weight cycling or yo-yo dieting. The weight loss through dieting is regained in weeks or months and maintained until the next attempt at dieting. This concludes Chapter 8, Part 2.